All right, let's jump right in. Today, we're going to tackle a really critical question in server management. How do we handle secure access? We're going to be unlocking how the Redfish standard gives us this powerful, super consistent way to control exactly who can do what across your entire data center. So let's just start with the main challenge, right? I want you to picture this. You're responsible for a massive data center, thousands of machines, all from different vendors. How in the world do you give the right people, and maybe more importantly, the right automation tools, the exact permissions they need without just creating a complete security nightmare? That is the core problem that Redfish Authorization was built to solve. So here's our game plan for this explainer. We're going to kick things off with the security challenge, then dive headfirst into Redfish's privilege model. After that, we'll get into the standard roles, see how access decisions are actually made, and then look at the secret sauce for automation, OAuth 2.0. By the end, you'll see exactly how all these pieces fit together. All right, first up, securing modern infrastructure. This is all about the huge challenge of managing access control when you're dealing with things at scale. You know, in the old days, before something like Redfish came along, every single hardware vendor just did their own thing. You'd have one set of security rules for this server and a completely different one for that server over there. It was a mess. This kind of inconsistency is a massive headache for security teams, and let's be honest, a total nightmare for anyone trying to write automation that just works. So how do we fix this mess? How does Redfish get us out of that vendor-specific chaos? Well, that brings us right to our second section. We're going to look at the elegant, simple solution at the very heart of the standard, the privilege model. First things first, let's get on the same page with the key term, authorization. Now, this is not about who you are, that's authentication. Authorization is all about what you're allowed to do once the system knows who you are. It's the bouncer at the door for every single action you try to perform. The first piece of this whole puzzle is the user. Pretty straightforward, right? This is just the account, whether it's a person sitting at a keyboard or some automated script that's logging into the Redfish service. This is our actor. Next up, we've got the role. Now, this is important. A user isn't just handed a giant, messy list of permissions. Nope. Instead, they get a single role. You can just think of a role as a container, a named bucket that holds all the specific permissions that user gets. And that brings us down to the most nitty-gritty part of the model, the privilege. Think of a privilege as the smallest possible unit of permission. It's the specific, granular authority you need to do just one thing, like, say, configure a network port or reboot a system. Okay, this is where it all just clicks together. I love this analogy. Think about it like a key card system in a big office building. The user is just the employee. The role is their job title, like IT operator or auditor. And the privileges? Well, those are the specific doors their keycard can actually open. So your IT operator keycard opens the server room, but definitely not the CEO's office. It's that simple. The user gets a role, and that role holds all the privileges. It's clean and it's powerful. Now that we've got the theory down, user, role, and privilege, let's see how Redfish actually uses this in the real world. In Section 3, we're going to look at the standard out-of-the-box roles that you'll run into. So right out of the box, Redfish gives us these 3 standard roles you'll find pretty much everywhere. And the magic word here is consistency. It doesn't matter if it's a server from vendor A or vendor B. If you have an operator role, it has the same set of base permissions. This gives you a predictable security baseline to work from, which, believe me, is a huge step up from the chaotic old way of doing things. Okay, so we've got these roles, and they're packed with privileges. But how does the system actually use them to make a decision? That's what this next section is all about. This is where we see how a request actually gets a thumbs up or a thumbs down. Let's get practical. You send an API call, you're trying to reset a server. What is actually happening under the hood? What's the logical flow inside that Redfish service that decides if you're allowed to do that or not? It's this really clean 4-step dance. First, your request hits the service. Second, the service looks at what you're trying to do, say a patch on a boot setting, and it figures out the exact privilege needed for that action. Third, it looks you up and checks your assigned role. And finally, it asks, is that required privilege inside the user's role? If the answer is yes, you get a green light. If it's no, you get hit with a 403 forbidden. It's that simple, that deterministic, every single time. Okay, this is awesome for when a human is logging in directly. But what about all of our automation tools? I mean, you're not going to hard code an admin password into a script, right? That's a huge security no-no. So how do we let our external apps and scripts manage the system without giving away the keys to the kingdom? And that question leads us perfectly into our next section, delegated authorization with OAuth 2.0. This is really the secret sauce, Redfish's powerful answer for doing modern, secure automation. Now, you've definitely used OAuth 2.0 before, probably a million times, even if you didn't know the name. It's the standard that powers all those sign in with Google or sign in with Facebook buttons. The whole idea here is delegation. You, the user, grant a specific, limited set of permissions to an application without ever giving it your actual password. And the way this all works is with something called an access token. For Redfish, it's a specific type called a JSON Web Token, or JWT. The easiest way to think about this is like a temporary, digitally signed keycard. Your automation script shows this token with every single request, and the token itself has a list of claims inside that state exactly what it's allowed to do and for how long. And here's where things get really cool and super powerful for automation. The permissions, which are called scopes in OAuth, can be granted in two main ways. You can grant a broad role, like the entire operator role. Or, and this is the game changer, you can get incredibly specific and grant just a single privilege. You could create a token that can only configure components and do literally nothing else. This is the principle of least privilege, and it's perfectly implemented for all your automation needs. Okay, we've gone through the nitty-gritty. For this last part, let's just zoom out, connect all the dots, and talk about why this model actually matters so much for anyone managing modern infrastructure. It really boils down to these four massive benefits. First, standardization. You get one security model that's consistent, no matter the hardware vendor. Huge. Second, granular control. You can define permissions right down to a single operation. Third, secure automation. OAuth 2.0 lets you build incredibly powerful tools without ever compromising on security. And finally, all of this leads to true interoperability. Your tools can talk to any Redfish service because they all speak the same secure language. So I'm going to leave you with this question to think about. Now that you've seen the building blocks of Redfish authorization and the power you get with delegated access, what's the very first manual, repetitive task in your own environment that you could now securely and confidently automate? It's a powerful thing to consider. Thanks for joining me for this explainer.